Hey, this is going to just be a quick video with the answers to your homework from over the weekend, page 13 and 14 in your Unit 13 packet. I'm just going to post them and talk about the answers. Let me share my screen. Good night. Love you. Okay, so I gave you the data in case you wanted to do the problems on this page. I know some people don't like having pages empty in their packets. These are the answers. You can push pause and check them out if you want. But basically, you can tell an endothermic reaction because the temperature of the water goes down and it feels cold. Exothermic, temperature goes up, feels hot. Endothermic, the salt goes to, hold on, if you have an endothermic reaction using the terms system and surroundings. So in an endothermic reaction, I don't know what this is, the heat goes from the surroundings into your system. And then, so that's written backwards. And then these are the equations. Okay, so I'm going to skip ahead to page 13 and 14. Okay, so for 13, here we go. See. Okay, so in this problem, here's your heat value. It's on the right, so it's exothermic. So in letter B, how many kilojoules is released? If this is what you're starting with, 2.5 moles of H2. The 1 came from the 1 in front of the H2 up there, and then the negative 185. I made it negative 185 because it's an exothermic reaction, and exothermic reactions always have a negative delta H. Multiply that together, negative 462. I don't know where this went. In letter C, this time you have 1 mole of HCl, so that's what I start with. I go up here to find the moles of HCl, so that goes on the bottom. Negative 185 equals negative 92.5. I don't know what happened to this page, why this is doing this. Oh, I don't know, this works for now. Okay. Okay, so in this one, oh my gosh, just move. Okay, in this one, it says use the table to find the delta H. So I looked up this equation in table I, and I found that it was negative 3,351. Since it's negative, that means it's exothermic. So I rewrote the equation and I just added the heat onto the end because that just means it's being released. How many kilojoules of heat are released if you have 4 moles? So this is our starting point. 4 moles of Al2O3. I got this 2 from the 2 right here. And then the heat goes right next to it, or on the top. So this is kilojoules, I didn't label it. Multiply, divide. There's your answer. On the next one, 1.5 moles of oxygen. So that's what I started with. 3 moles of oxygen on the bottom from 3 right there. And then the heat value on top. And then this one is backwards. I didn't teach you how to do this one. So you have 1,000 kilojoules of heat right here. And I need the unit to cancel, so I'm going to put kilojoules on the bottom. So this is kind of like the reverse of what's happening in letter C and D. So the kilojoules goes on the bottom. And then it's asking you for moles of aluminum. So then I went up to here and I looked. The formula has a 4 aluminum, so it's just 1. 0.19 moles of aluminum. All right, number 5, same thing, use table I. I got 227.4. It's positive, so it's endothermic. 2 moles of C2H2 will be your starting. If you look in the reaction, there's only 1, so that's where I got the 1. And then the 227.4 goes on top and multiply. Letter C, what's the total amount of heat absorbed when 1 mole of carbon reacts? Starting value here, 1 carbon, 2 carbons on the bottom, 227.4 up top, and then multiply 5 by 2. And then letter D is just like the one up here. So you're starting with the heat, kilojoules, kilojoules on the bottom to cancel. The value is right here. And then they're asking for moles of hydrogen. So I look up at my formula and there's only 1 hydrogen. So that's how I knew it was a 1. All right. And then on to the next page. All right, had technical difficulty there. Okay, so in this next one, oh my goodness gracious. Okay, so it says you have 101 kPa, 298. That's not relevant. So basically, this is a tricky question because they don't really tell you a whole lot. What is the total amount of heat when 1 mole of aluminum oxide is formed from its elements? So that means you need to go into your formula, into table I, and look for where it says Al plus O2 yields Al2O3. And it'll have a 4, and it'll have a 3. The value for that is negative 3,351, but that's for 2 moles of aluminum oxide. So basically, to figure out your answer, you just need to divide that. Okay, in number 2, you're given the reaction and you're given your delta H value. The approximate delta H for formation of 1 mole. So start with 1. 2 is right here on the bottom. And then I made this negative because it's delta H is negative when it's exothermic. And that's that. Okay, and then the next 2 are the ones that are usually troublesome. All right, so let's talk about these. Sure. Okay, so it says a student is holding a test tube containing 5 milliliters of water. When a sample of NH4 is placed in the test tube feels colder, so the temperature goes down. Describe the direction of heat flow between the test tube and the hand. So since the temperature of the water is going down, the heat is flowing in to the salt, making it an endothermic reaction. So heat is going, and it's making your hand feel cold. So the heat from your hand is going to the test tube, okay? And that's why it feels cold. In number 4, when a person sweats, the body loses sodium ions and potassium ions. The sweating cools your skin. Describe the transfer of energy between the skin and surroundings as a person perspires and sweat evaporates. So we're sweating, well, super hot from working out, and the steam is going off your skin. So the heat from your skin is flowing into the environment, which leaves the skin that's left over feeling nice and cool. And that was your homework. So only have to listen to for this video.